ambiguity and ambiguity in this. The choice of variables and scaling parameters. The equation of the falling body that represented as S0 plus V0t plus the last part is half of gt squared illustrated most concept of the dimensional analysis. It contains 5 terms, as we said before. S, sequentially S0, V0, T and G, which we may divide in our thinking into variables and parameters. The variable are the things we wish to plot. So the variable are those we wish to plot the basic output of experiment or theory. In this case, S versus T, in this relation, S versus T is the variables. The parameters are those quantities whose effect on the variable we wish to know. So we have variables here, and the parameters are those quantities whose effect on the variables we wish to know. Whose effect on variables we wish to know. These variables return to the definition here, choosing that we choose S and T in this equation, and for the parameters S0, P0 and G. Are the parameters in the our analysis. Almost any engineering study can be subdivided in this manner. To non-dimensionalize our result, we need to know how many dimensions are contained among our variable and parameters. In this case, only 2, length and t, are the dimensions that we maybe encounter in this dimensional analysis for the falling body curve motion. Let me write again the falling body equation. So as we said, to non-dimensional our result, we need to know how many dimensions are contained among our variables. In this case, we have L on T multiplied to T. In case L on T2 multiplied to T2. So the only variable, the only dimensions are L and length and top. Among our parameters, we therefore select the scaling parameters, also called repeating variables. So we should choose the scaling parameters. Also called repeating variables. Used to define dimensional variable. What remains will be the basic parameters whose effect we wish to show in our plot. This choice will not affect the content of our data, only the form of our presentation. Clearly, there is ambiguity in this choice, something that often vexes the beginning experimenter. But the ambiguity is deliberate. Its purpose is to show a particular effect, and the choice is yours to make. For the falling body problem, we select any two of the three parameters to be scaling parameters. In this case, the parameter was S and G. We can select any of these parameters as scaling, thus we have three options. Let us discuss any display them in turn. Option 1. Scaling parameter S0 and B0, the effect of gravity. So we have three options for this type of problem to scaling the, for example, experiment. Considering the equation of falling body motion, again S0 plus, we are going to describe various option 2 scaling done. Option 1, we select the scaling factor at S0 and P0 scaling factor, and the effect of gravity G. First, use the scaling parameters as 2 S0 star and P0 star. They are scaled parameters. There is only one suitable definition for each. We to make dimensionalized scaling down, we have to find an expression for each variable to scaling down. In this case, S star is the S on S0 and T star from the equation. Substitute this variable into the previous equation and clean everything up until each term is dimensionless. The result will be as here. In this case, s equals to s star s0, and in this case we can calculate t0. We have t star s0 on b star, replacing to the equation of motion. We can obtain this relation. One plus t star plus t star 2. Okay, this is s. And also here we have s. With replacing, we can obtain the relation which contain non-dimensional parameters, variables. In this relation, alpha equals the g can be obtained with simplification. It is not a constant, it is depend on our problem. The option 2 is scaling parameters. P0 and G. The effect of initial displacement and effect of initial displacement is 0. Now use the new scaling parameters. Our scaling parameters are P0 and G. We should obtain the variables as non-dimensional. Depending on our scaling parameters, we can write S star. We should have a length scale above the division, which is S multiplied to G, for example, on V0. And for T, also we can obtain a relation. For example, in this case, we can write a mathematical expression to calculate the length. In this case, we can write T. Let me T star TA G, for example, B, and B, for example, the power C. So we should have T in right hand side, left hand side, and T in right hand side, TA multiplied to, for G we have the L on T to B and LC on TC equals to TA multiplied to let me write L B minus C multiplied to T C minus 2B, which equals to T A plus C minus 2B L B minus C. Now we can calculate our unknowns powers. B minus C 0 b equals to c and a plus c minus 2b equals to 1. Well, replacing to the relation, we can obtain a minus b equals to 1. In this case, we have b equals to c, a minus b equals to 1. Because it is a scaling parameters, we can choose any of powers. 1, we can start because t a we can choose a equals to 1 and b equals to 2, and we can also choose c equals 2. The other non-dimensional parameter for t star will be obtained as the relation t star equals to a equals to 1 and b and t are equal, and we can write only the division of them, because in a dimensional case the dimension of each parameter is divided to the another eliminated the power of parameters. This is our t non-dimensional variable. With replacing, we can obtain the relation for the falling body curve motion is a star alpha plus t star plus star 2. In this case, alpha equals to g s star This is option 2 for our scaling down. The option 3 is option 3, scaling parameters S0 and G. The effect of initial speed. In this case, for example, in an experimental, where our desire is to find the effect of initial speed, we choose scaling parameters S0 and G for scaling. So our variable was S and T. We should calculate the relation for S star and T star. In this case, S star can be, we should write an expression for the non-dimensional in the variable S on S0, and in this for T we are going to non-dimensional T and a function of T multiply. We should obtain a relation between G and T. You can also use the power relation, but you can also find an expression between G and S that dimensionally equals to a non-dimensional case. We know G dimension is L on T2 and S is L. So if we divide G on S0, we will obtain 1 on T2 to eliminate the last dimension, which is T, with the available T here. We should consider the 1 second power of G on S. This is our two variable scaling down parameters for the falling body curvature. So S star equals to 1 plus beta T star 2, and beta equals to the relation of obtaining alpha in previous calculation. Note that in all three options the same parameters alpha appears but has a different meaning: dimensionless gravity, initial displacement, and initial velocity. The graph which contain exactly the same information change their appearance to reflect these differences. As we said, these three options depends on our desired output result from experiments. It is the next end of this section. Next section is about the selection of scaling variables, repeating scaling variables.